Hello everyone, this is Cody Jackson for Cody. Sorry been away for a while, things have been busy, my computer crashed the other week, but here we are, back in business, and we are continuing with the Python series, and we're going to be taking a look at exceptions today. You've seen this before if you've seen the other videos, the books that I'm using to generate these series for you. One thing that I want to note that I don't think I've explicitly stated before, but all the code that you see in these video series is in these books, so you can pause the videos to get the code, or you can have a book and follow along in the book, or you can go to the repository associated with the book and download all the code directly, and that way you don't have to hand write any of the code. So that's just a useful suggestion. Moving on, like I said, we are going to talk about exceptions. So exceptions are used for error handling in a large number of programming languages. Not every programming language has exceptions or some sort of error handling like that. Sometimes it's usually left up to the programmer to manually figure out how to deal with that. But Python does have exceptions. So exceptions are events that modify normal program flow, whether by design or because there are errors. They are not part of the normal flow of logic and thus are exceptions to the rule. And so they are primarily used to check things like whether a file exists, if you've reached the end of a file, if you're reading line by line, changing the flow of logic if you hit an error so that the user can continue working, things like that. They handle unexpected errors, or they can also be manually generated by the developer depending on the needs of the program. Primarily they are used to minimize the effects on the user while also allowing a way to capture bugs or difficulties within the code and automatically upload that back to the developer so that those bugs can be fixed in the next patch. Another added benefit that isn't commonly talked about is for programming security. If errors are not shown on the screen, then it is very unlikely that somebody will be able to use those errors to backtrace your code logic and figure out where security vulnerabilities might be. And so if you are automatically capturing those errors and dealing with them and not telling the user that there was a problem, then obviously that makes your program slightly more secure in that it's just a little bit more difficult to easily find those access points into your code by sending known issues that will break it. If you're using the interactive interpreter, such as IPython, you're probably not going to be throwing some exceptions in there unless you're explicitly trying to test whether a exception block is going to work the way you think it is. And the reason for this is because the interactive interpreter provides you immediate feedback, so you know if you're going to be getting an error or not, and you can account for that in your regular code. Manually raising an exception may be necessary. As I talked about, some developers will manually raise an exception to handle specific issues that are programmatically correct, but not the intention of the developer. And so they will manually raise an exception and capture that to deal with it, rather than just kind of letting the program do its own thing and kind of go down a rabbit hole that will eventually break stuff. Exceptions are not processed until an error is actually generated or an exception is thrown. Therefore, they can help reduce the processing overhead of your program. Where this comes into play is if you're using if-else blocks. When you have an if-else block, all of those conditions are going to be checked every single time. If you have a an else condition that maybe only occurs 5% of the time, you don't necessarily want that logic code, especially if it's very heavy in terms of processing, to be checked every time and wasting processing cycles. If you change that if-else block into a exception block, then you can assume that the code is going to be doing what it does 95% of the time, and then that 5% of the time when that unusual condition occurs, you just throw an exception and you deal with it at that time. That way your programming logic is not wasting additional time on the overhead of multiple if-else statements that don't apply to the condition, to the operating conditions, 95% of the time. Another benefit of having exceptions in there is because they do function like if-else blocks. You could do the exact same thing with if-else blocks, but by having explicit error checking code within your exception area, then it helps segregate your code so you can easily see where your error checking is, where your normal if-else coding logic is, and so you don't have to kind of stumble through your code to figure out if you've checked for a particular condition or anything like that. So this time we're going to jump over into a actual demonstration of try and except clauses within programs, so you can see how exception blocks actually work. I'm not using IPython this time. I am using the Python integrated development environment, and you'll probably see this more often in the future as we start getting into actual regular sized code that doesn't necessarily need an interactive interpreter like IPython to work with. So going through this line by line, line 1, we are defining a function. We haven't talked about functions yet. That's actually in the next video. Don't worry about that. Line 2, we are defining a variable. Number 1, we are saying that we are capturing user input via the input function, and we are telling via a prompt in the command line to the user, enter the first number. We do the same thing in line 3 for a second number. Line 4 is where we actually start the exception block. So exception blocks have a try and except. The try part defines a block of code that is going to be ran and then checked to see if a particular error message is thrown. If a particular error message is thrown, then your except blocks will look for that, capture it, and then do something with that specific error message. In this case, you can see in line 8 we have except value error, and in line 10 we have except zero division error. So there are two different errors that we're looking for, and we will handle both of those. If any other type of error shows up, we're not capturing it, and so we will get that error printed out to us. Otherwise, we will capture one of those two errors, gracefully handle it, and not break the program. You'll see what I mean in a second when we actually run through the program. So with the try block in line 4, it is going to capture the number 1 and number 2 input from the user, which are normally gathered as text strings, convert those to float values, divide those, and provide a result. If the user does not provide both number 1 and number 2 input variables, then a value error is generated saying 2 numbers are required. If the user says number 2 is going to be 0, then we're going to capture a zero division error and say 0 can't be the denominator, and any other error that's generated is not going to be captured. The code just jumps right to else, print the result. So basically the primary part of the exception block is going to be this here, the try and the 2 accepts. else is considered part of it because it's really if else. So this is really one big if. An error is generated, do whatever, else continue normal logic flow and print the result. So if we run this code, then we come down here to our command prompt, and it basically says enter the first number, and we give it a number, enter a second number, we give it a number, and it gives us the output right here. You can see that it has converted them to floats, and it gives us the number as the result as a floating point number. If we run it again, we can see how the two different errors that we are looking for work. So if we give it a first number and we don't give it a second number, then it's going to just tell us two numbers are required. Then throw out a ugly error message that might scare the user. It's just a very nice, two numbers are required, please start over. And obviously you could go in and you could put this into a loop that would continually run until it gave, or I should say, got the input that it expected, or however you wanted to define the loop. If we run it again and we give it a 0 as the second number, then it's going to say 0 cannot be a denominator. And then, as you saw in the first example, if we give it two different numbers, then it will decide what the result is of that. Now, if you wanted, rather than having these two input variables separate, you could actually put them into the try block. So if you put the calls to the user in the try block, you've basically eliminated an extra step. And so now, as part of the try, we are going to capture the input from the user, immediately turn it into a float value, and assign that to our number 1 and our number 2. The rest of the logic is all the same. We've just kind of combined the object, or the logic of asking for the objects from the user into the try block, where it would convert those to floating point values. Another thing you can do is set up a finally call, and so after everything is done within your try block, finally is going to run regardless of whether an exception was generated, and is basically used to perform some sort of an action, such as closing files, severing server connections, things like that. So basically any sort of end processing that you want to do, regardless of whether the errors were generated, you can set into a finally block. So in this case, if we run the program again, we give it some numbers, you'll see that it generates the result, and then as it's on its way out of the program, it handles the finally block and tells us finished processing. If we go over to the python.org website and take a look at the official documentation, you can see all of the exceptions that are provided by Python simply by virtue of running Python. Third-party libraries may have their own exceptions. You as a developer can create your own exceptions as well. All you have to do is inherit from the exception class and then just define your exceptions that way. That's beyond the scope of this particular video, but it is mentioned in my book if that is something you're interested in. So it does talk about the basic classes for exceptions, how to use them in terms of what they're looking for and when they're raised and things like that. Further down, something that I use very frequently when I am working with exceptions is the hierarchy. So this is where you can see how granular a particular exception is. So if you're doing something math related, you have your arithmetic error, which is the base error for all sorts of math type of programming. Not all math, but floating point errors, overflow errors, zero division errors, things like that. You have end of file errors. You have import errors if you're not able to import a file that's expected to be there. OS errors. Those are very common because it handles pretty much anything that deals with the operating system. So file system access, so file exists, file not found, is a directory, is not a directory, permissions errors, stuff like that. And then it also gives you a variety of warnings that you can use in your program. Most common you'll see is probably deprecation errors. As code is getting ready to change, you may get one version of that code that's going to have deprecation errors, and so that's going to give you months or years to plan on changing your code to what the new version is going to be, and it depends on obviously the developers what the timeline is for the new version, but you're allowed to have that deprecation warning in there, indicating to other developers, stop using this particular call, use the new call, because this old one is going to disappear in a future version. So that's it for this video. In summary, we examined the purpose of exceptions, we looked at appropriate uses of exception handling, considered alternatives of using exceptions for if-else blocks, looked at the hierarchy of the Python exceptions, and we briefly discussed the user-defined exceptions, but like I said, we didn't look at it too close because it's beyond the scope of this particular video. Just recognize that you can create your own custom exceptions based off of one of the existing exceptions. So you can use a base exception, or you can use a specific one. So for example, say you wanted in that number division program that we had, if you wanted to check for negative numbers, which we didn't have in there, you could create a negative number error from value error. So it's going to use the same functionality that value error has. The only difference is it's going to be explicitly looking for a negative number or a negative value, and then process that as an exception. Hope you learned something. Hope you enjoyed this video. Next time we're going to talk about functions, which has been a long time coming, but functions are really the workhorse of getting your programs to do stuff. So at this point is when we're actually really going to learn how to start using Python to do stuff. Object-oriented programming is further down the road. It's not necessary. You can use Python completely using functions and get by just fine. So after the next video, you should have enough information to start making your own small programs and just play around with it. So, like I said, I hope you enjoyed this video. If you have any comments, concerns, questions, please let us know in the comments. And until next time, have fun, keep trying, keep experimenting. Bye.